Right now, somewhere in the depths of space, a star the size of our entire solar system is tearing itself apart with the force of 10 octillion nuclear bombs. You think that sounds powerful? Wait until you meet the cosmic monsters that make dying stars look like flickering candles. Black holes that devour light itself. Mysterious forces ripping apart the fabric of reality. And events so violent they could erase our galaxy in seconds. If this journey through the universe's most devastating powers sounds incredible, hit that like button and subscribe for more cosmic adventures. Prepare yourselves. We begin. The surface of our sun just exploded. In the time it takes you to blink, a magnetic field line the size of Earth snapped like a rubber band, hurling superheated plasma into space at 2 million of. This solar flare carries the energy of 10 billion nuclear warheads. And it happened because our supposedly stable star is actually a rowing ball of controlled chaos, constantly building and releasing magnetic tension that would vaporize our planet in seconds. Picture the sun as a massive electromagnet wrapped in molten metal. Deep inside, nuclear fusion creates temperatures of 27 million F, hot enough to strip electrons from atoms and create an electrically charged soup called plasma. This plasma moves in complex patterns, twisting and knotting magnetic field lines like invisible cables stretched to their breaking point. When these magnetic cables finally snap, they release energy equivalent to 20 million volcanic eruptions happening simultaneously. The explosion fires a burst of X-rays that reaches Earth in just 8 minutes, followed by a wave of charged particles traveling at nearly the speed of light. If you were an astronaut outside Earth's protective magnetic bubble during a major solar flare, the radiation would cook your cells from the inside out in minutes. But here on Earth's surface, we experience something far more beautiful and terrifying. The charged particles slam into our planet's magnetic field, creating the aurora borealis and aurora aurelis. Those dancing green and purple curtains of light represent millions of particles moving at 600 meters per second, guided by invisible magnetic highways toward our poles. The most powerful solar flare ever recorded happened in 1859 when telegraph wires sparked and caught fire across Europe and North America. Telegraph operators received electric shocks, and some telegraph systems continued working even after being disconnected from their power sources, running purely on the electrical energy pumped into Earth's atmosphere by our angry sun. Today, a flare that size would shut down satellites, collapse power grids, and knock out internet cables across entire continents. GPS systems would fail, leaving ships and planes navigating blind. The estimated damage would reach $2 trillion, and it could take years to repair the infrastructure. Solar flares follow an 11-year cycle, building to a solar maximum when our sun fires off dozens of major flares per month. During solar minimum, flares become rare, but they never stop completely. Our sun is always building magnetic tension, always preparing for the next explosive release. The strangest part, scientists still can't predict exactly when or where the next major flare will occur. We can watch the magnetic field lines building and twisting on the sun's surface, but the moment of release remains as unpredictable as lightning during a thunderstorm. Think 10 billion nuclear bombs sound powerful. Our sun produces flares like this regularly, treating world-ending energy as nothing more than a magnetic hiccup. However, compared to what comes next, solar flares are gentle whispers in the cosmic conversation. Beneath Yellowstone National Park, a bubble of molten rock the size of Los Angeles is growing. This magma chamber sits just 5 meters under your feet if you visit the park's famous geysers, and it contains enough superheated rock to bury the entire United States under 3 feet of volcanic ash. When this monster finally erupts, it will make every volcano in recorded history look like a birthday candle. The explosion will be heard 3,000 meters away, and the ash cloud will plunge the northern hemisphere into a volcanic winter lasting years. Supervolcanoes work like pressure cookers from hell. Deep beneath the Earth's crust, radioactive decay and gravitational pressure create pockets of magma hot enough to melt steel. Unlike regular volcanoes that build cone-shaped mountains, supervolcanoes hide their power underground, creating vast chambers that can stretch for hundreds of miles. Think of it as a massive balloon filling with molten rock under enormous pressure. The balloon keeps expanding until the ground above it can no longer hold the weight. When it finally gives way, the entire chamber empties in one catastrophic explosion that shoots debris 50 meters into the atmosphere at supersonic speeds. The Yellowstone supervolcano has erupted 3 times in the past 2 million years. The most recent explosion, 640,000 years ago, ejected 240 cubic miles of rock and ash. That's enough material to bury the entire state of Texas under 2 feet of volcanic debris. The eruption created a crater 34 meters wide and 50 meters long, which we now call the Yellowstone caldera. The eruption 74,000 years ago at Lake Toba in Indonesia nearly drove humanity extinct. The explosion launched so much ash and sulfur dioxide into the atmosphere that global temperatures dropped by 21 degrees F for several years. Archaeological evidence suggests the human population fell to just a few thousand individuals, creating a genetic bottleneck that we can still detect in our DNA today. When a supervolcano erupts, it doesn't just destroy the local area. The ash cloud spreads across continents, blocking sunlight and causing global climate change. Plants die from lack of sunlight, leading to mass starvation as crop yields collapse worldwide. The sulfur compounds create acid rain that poisonates water supplies and strips leaves from trees across entire continents. Scientists monitor Yellowstone constantly, measuring ground deformation and earthquake activity. The caldera floor has been rising and falling by several inches per year as the magma chamber below expands and contracts like a breathing giant. Small earthquakes happen daily, reminding us that this sleeping monster could wake up at any moment. The truly terrifying part, supervolcanoes operate on geological timescales that make human planning meaningless. Yellowstone erupts roughly every 600,000 years, and we're overdue by 40,000 years. Every day that passes brings us one day closer to an explosion that could end modern civilization. But even supervolcanoes pale in comparison to the raw electrical fury that strikes our planet 5 million times every single day. A single lightning bolt just delivered more electrical power than the entire city of New York uses in 15 minutes. That flash of light lasted only 2/10,000 of a second. Yet, it carried 5 billion joules of energy and reached temperatures of 50,000 degrees F. That's 5 times hotter than the surface of the sun. Hot enough to instantly vaporize sand into glass and split nitrogen molecules in the air, creating the thunder that shakes your bones. Seconds later, lightning forms when nature builds the world's most dangerous electrical circuit. Inside thunderclouds that tower 10 meters high, ice particles collide and transfer electrons like billions of tiny generators working simultaneously. The top of the cloud becomes positively charged while the bottom turns negative, creating an electrical difference of 1 billion volts between sky and ground. Imagine the cloud as a massive battery with positive and negative terminals separated by miles of air. Air normally acts as an insulator, preventing electricity from flowing between the cloud and ground. However, when the electrical pressure builds high enough, it overcomes this resistance and carves an invisible pathway, called a stepped leader toward Earth at 200,000 miles per hour. The moment this pathway touches the ground, a return stroke of pure electrical energy rockets back up the channel at 1/3 the speed of light. This return stroke creates the brilliant flash we see carrying 30,000 amp of current. To put that in perspective, your household electrical outlet delivers just 15 amp, and anything over 10 milliamp can stop your heart. The electrical channel becomes so hot that it instantly superheats the surrounding air, causing it to expand faster than the speed of sound. This creates the shock wave we hear as thunder, which can shatter windows and damage buildings up to 10 meters away from the strike. Some lightning bolts stretch horizontally across the sky for over 100 meters, connecting multiple storm systems in a single massive electrical discharge. These bolts, called positive lightning, carry 10 times more energy than regular strikes and can jump 25 meters between clouds and ground. Ball lightning represents one of nature's strangest electrical phenomena. Witnesses report glowing spheres the size of basketballs that float through the air for several seconds after lightning strikes, sometimes passing through solid walls without leaving marks. Scientists still can't fully explain how these electrical orbs form or why they behave like they do. The most powerful lightning happens on other planets. On Venus, lightning bolts stretch across distances larger than Earth itself, while Jupiter's storms create electrical discharges 1,000 times more powerful than anything on our planet. Saturn's lightning produces radio waves so strong they interfere with spacecraft communications from millions of miles away. Every second somewhere on Earth, lightning strikes the ground 100 times. That's 8 million strikes per day, each one carrying enough energy to power a typical American home for 3 weeks. The planet essentially operates as a massive electrical generator, constantly transferring energy between the atmosphere and ground through channels of superheated plasma. Yet, even this tremendous electrical power becomes insignificant when humanity learned to split the atom itself. The most powerful nuclear weapon ever detonated shattered windows 300 meters away and registered as an earthquake around the world. The Soviet Union's SAR bomber released 57 million tons of TNT equivalent in a single explosion, creating a mushroom cloud that rose 39 meters into the atmosphere and a fireball 5 meters wide. The flash of light was visible 600 meters away, brighter than the sun at noon. The bomb was so powerful that its designers had to reduce its yield by half because they feared it might ignite Earth's atmosphere. Nuclear weapons work by unleashing the fundamental forces that power stars. In fission bombs, uranium or plutonium atoms split apart when struck by neutrons, releasing massive amounts of energy and more neutrons that split additional atoms. This chain reaction happens faster than you can blink, with each generation of splitting atoms releasing exponentially more energy. Think of it like a room full of mousetraps, each one balanced with 2 ping pong balls on top. Throw one ball into the room and it triggers a trap that launches 2 balls. Those 2 balls trigger 4 traps launching 8 balls, which triggers 16 traps, and so on. Within microseconds, every trap in the room explodes simultaneously. Fusion bombs take this concept even further by forcing hydrogen atoms together under extreme pressure and temperature, mimicking the process that powers our sun. The energy required to start fusion comes from a fish bomb used as a trigger, creating temperatures of 100 million F in a space smaller than a baseball. The physics becomes terrifyingly elegant when you understand Einstein's famous equation. A tiny amount of matter converts to enormous amounts of energy. In nuclear weapons, less than 2 pounds of matter actually converts to pure energy. Yet, this creates explosions equivalent to millions of tons of conventional explosives. Modern nuclear weapons use sophisticated designs that maximize destruction while minimizing radioactive fallout. Multiple stages of fission and fusion reactions amplify each other, creating bombs thousands of times more powerful than the weapons that destroyed Hiroshima and Nagasaki. A single modern warhead can level an entire metropolitan area and render hundreds of square miles uninhabitable for decades. The global nuclear arsenal contains enough weapons to destroy human civilization multiple times over. Countries like Russia and the United States maintain thousands of warheads, each one capable of eliminating major cities. The combined explosive power of all nuclear weapons equals roughly 1.5 billion tons of TNT, enough to excavate a canyon from New York to Los Angeles. Submarine-launched ballistic missiles can deliver these weapons anywhere on Earth within 30 minutes. The warheads re-enter the atmosphere at 15,000 miles per hour, guided by systems accurate enough to hit targets within 300 feet from thousands of miles away. The ultimate irony. Humans created these weapons by studying the same nuclear processes that occur naturally in dying stars, where gravity crushes matter so violently that atoms themselves surrender to forces beyond imagination. In the constellation Orion, a star 700 times larger than our Sun is running out of time. Betelgeuse burns through nuclear fuel at such a furious rate that it will consume its entire supply in just a few million years compared to our Sun's 10 billion-year lifespan. When this red supergiant finally collapses, it will release more energy in 10 seconds than our Sun produces in its entire lifetime. The explosion will be visible from Earth during daylight hours for weeks, shining brighter than the full moon. Massive stars die in the most violent explosions the universe can produce. For millions of years, nuclear fusion in the star's core creates outward pressure that balances the inward crush of gravity. The star burns hydrogen into helium, then helium into carbon, carbon into oxygen, and oxygen into silicon. Each fuel burning hotter and faster than the last. Picture the star's core as a series of nested furnaces, each one burning a different element. The outermost layer burns hydrogen at 18 million day F. Deeper inside, helium burns at 180 million dig. At the very center, silicon fusion reaches 5 billion dig, hot enough to create iron in nuclear reactions that last only days. Iron becomes the star's death sentence. Unlike lighter elements, iron fusion absorbs energy instead of releasing it. When the core fills with iron, nuclear reactions stop instantly. Without outward pressure from fusion, gravity wins the ultimate battle in less than 1 second. The core collapses from the size of Earth to the size of Manhattan in the time it takes you to say supernova.